Hello students. So in my last lecture I have told you about uh, I have started the unit 1, and in unit 1 you can find that we have the embedded system and general purpose computing systems. So now today we will find the aspects of history of embedded system, that how the embedded system can has developed. So for this we have already covered that the embedded system block diagram, and in this block diagram you can find that there is a processor, there is a control output, there is observe input and memory. So there is a system bus also. So whatever the things are over there, we just program the things and we store the programs in the memory, and this memory this processor works on the instructions which we write it in the memory, and the processor starts to observe the things, whatever the, here is the example of a temperature sensor we have taken. So it is observed by the temperature by the processor, and if a thing start, means if a threshold comes of a temperature sensor, then some control output are over there. For example, if the temperature goes beyond 25 degrees centigrade, then some motor will be on. So such type of things happens in a embedded system. So what are the types of embedded processors? There are computational processors, and computational microprocessors are 32-bit or 64-bit byte. So for example, CPU of a workstation, PCs or high-end portable devices are the 32-bit or 64-bit microprocessors. So these are general purpose computing system, but these are the embedded system. These are not too big and used handheldy, and we can use them on our palm tops, and they can be used easily. So the basic architecture depends on x86 architecture, and RISC type architectures are also there, and Power PC and Spark, these are all the example of computational microprocessor. Next is embedded general purpose micros, means these are 32-bit data path, and they can handle 32-bit information at a time, and they can they can easily manipulate the 32-bit information at a time. Designed for a wide range of the embedded application. And often scale down the version of the computational micros. The ARM processor and Power PC and mega instructions per cycle, x86 68 kilobyte structure. So these all things are the characteristics of embedded general purpose systems. Some small microcontrollers are also used in the terms of the 4-bit, 8-bit and 16-bit data path, and they are used with the integrating microprocessing unit and memories and input-output buses and peripherals. Often low cost and high volume devices are used for with these microcontrollers. Some domain specific processors are also there. For example, if you want the red light, and the red light should work only in 3 domains with a time domain, so this red light microprocessor is the only one and can be used easily, and we no need to this is a domain specific processor and can be used for the same purpose. Similarly, we can use the network processor, security processors, graphics processors. So these are all the domain specific processors which are be used in a embedded system. So there is a processor market, and in 2001 the computational microprocessor were 2% only. Embedded general purpose computer microprocessor is 11% of the total market, and DSP processor are of 10%, and microcontrollers holds maximum of 80% market. 2001 processor market by revenue, computational 51%. So computational micros has the 51% micros, and embedded system general purpose microprocessors are 8%, DSPs are 13%, and microcontrollers are 28%. So this is the total revenue of the in 2001. Higher growth expected from the embedded micros and DSPs and microcontrollers. Here you find a simple difference. You can in some years, 2001 to 2006 years. So in 2001, it works for the $4 billion, less than $4 billion. Then it grows up to the $5 million, and then it grows up to less than $6 billion. And you can find it as the time increasing, the growth of the market of the embedded system microprocessors are increasing worldwidely. Okay, so you can find that over 97% of the total processors is sold, and over 60% of total sales from the processors. So sales expected to increase by thoroughly 15% each year. Okay, so here the Moore's law exhibits, and Moore's law capacity doubles every 18 months. So you can find that you can find this type of the diagram where where we are starting from 1968, and after 1969, in 1969 we have the capacity of the transistor per chip less than 100, and in some and as the time is increasing, so number of the transistors per chip are also increasing. And in you can find that this is the these are the microprocessors which we build in our history, and this is the growth of the microcontrollers and microprocessors in the history. Here you can find that in till the 2000 we have the P4 type of microprocessor which has billions of the gates on a single chip. So you can find that in 1981 it was the 10,000 transistors leading edge chip in 1981, and after that the chip size get reduced, and in 2002 there is a 15 million transistor on a 150 million transistor on a single chip. So in my next lecture I will tell you about the characteristics of the embedded system. So thank you for this lecture.